I know it's going to be bigger than 5-2 because 5-1, 5-2, and 5-3 are all, if it's a parallelogram, then
Isn't it
5-4.
5-6?
5-6. It is going to be theorem 5-6. It's okay if you didn't memorize as long as you knew what it said.
Pretty cool.
Theorem 5-6 Theorem 5-6 basically says if both opposite pairs of angles are congruent, then it is in fact a parallelogram. But that goes back to exactly what you said, that it's based upon the fact that it creates parallel lines. And that's how you proved it as well. All right? So Theorem 5-6 says that all rectangles are in fact parallelograms. I don't think it's a hard thing to buy into the fact that that's a parallelogram. Theorem 5-12, the diagonals of a rectangle are congruent. The diagonals of a rectangle are congruent. That's important to know. All diagonals of a rectangle are congruent. And Theorem 5-16, if an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. I'm going to put a little note on the side of what exactly that means, and you can either put it here, or you can put it on yours, or you can be like, duh, I don't need to write that at all. What this is saying is basically if you have a parallelogram, and you say one corner of it is a right angle. Let's call this A, B, C, D. So this is A, B, C, D, and all it said was, hey, angle A is 90 degrees. Well, based upon that one little fact, I don't have much room here. You should have a little more room on your side. A, B, C, D is a parallelogram. And not just a parallelogram. It's going to be a rectangle. So it is a parallelogram, is a, I just ran out of room, rectangle. Yeah, Evan.
Well, couldn't it be like A and B, angle A and angle B are 90 degrees, and then angle, like, I say D is 91, and angle C is 89?
For that to work, the top and bottom would have to go in different directions, and they'd no longer be parallel. So as soon as one is 90, and it's a parallelogram, so maybe we should note that on here. It's a parallelogram, so that's parallel to that. And CD is parallel to AB. We just need to know one of these corners is 90. If it's a parallelogram, that means the side opposite, or the corner opposite it, is going to be 90, so that has to be 90. And these two angles have to add up to 180, so they all have to be 90. So if I say something's a parallelogram, and I say one of the angles is 90 degrees, you can use all your other theorems to say, hey, the rest of them need to be 90 as well, so it must be a rectangle, because rectangle, the only thing that defines rectangle is it has to be a quadrilateral, 4 sides obviously, and all of our angles are 90 degrees. Yeah?
Why is that a rectangle and like not a square?
A rectangle can be a square. A square is a specific type of rectangle. Kind of like all thumbs are fingers, and all fingers aren't thumbs. All squares are rectangles.
All
But-
thumbs are fingers?
All thumbs are fingers, but not all fingers are thumbs. It's the same thing with rectangles. All squares, hold on. All squares are rectangles, but not all rectangles are squares. And we'll get to that, okay?
It's like a subcategory, like length.
Yes. And we'll get to that in just a second. So let's just stick on rectangle right now. You have a whole section on square coming up. Let's hold our breath on. It's not a whole section. You'll see. It's just it's a drawing. All right. Here is probably the most missed thing on any test and homework. It is this theorem. Theorem 515 is probably the most missed because it's sometimes the hardest to see. 515 says the midpoint of the hypotenuse, got to meet all these requirements. It's got to be the midpoint. It's got to be the hypotenuse of a right triangle is equidistant to 3 vertices. So from our rectangle, remember it's a parallelogram, so each thing is bisected. Each of our diagonals is the same length, so each little section, and maybe I'll highlight it, each little section of our diagonal has to be the same length as the other side, which would be the same length as over here, which is the same length over here. I would not circle, I'm just doing it for sake of the video because I'm talking about something that, if you're watching it, you have no idea what I'm talking about. I'm just saying all four of these sections are congruent. So that means if I take off this top part, and I just have this, well, that point right there must be a midpoint. So this is a right triangle. This is the midpoint. And why this is interesting is look at the isosceles triangles it forms. Yeah.
Oh, that's great.
That's why it's one of the most missed things, because people just kind of forget about the fact that, hey, I have an isosceles triangle there.
Whoa.
I also have an isosceles triangle here. Which means if I know this midpoint and I know this angle, I also know this angle, right? So if I had this and I knew this angle, I could go ahead and find that little angle over there. That's why it's one of the most missed things, because a lot of times if I say this is 6, you're like, oh yeah, 6 and 6. But as soon as I start dealing with angles, people just lose their mind because you kind of forget about isosceles triangle having base angles being congruent. But we have to know that when we get to something like this. All right, so then I came up with a couple of examples just because people tend to miss these problems. So the first one says, if angle KAP is a right angle, has to be a right angle, has to be a midpoint for us to use this. So it says that KAP is a right angle, awesome. And AM is a median. A median, remember, a median goes from the vertex to the midpoint of the other side. So by me saying AM is a median, this immediately means that this is a midpoint. Remember, a median just says it goes to the midpoint of the other side. So then it says MA equals T. So KP equals, who wants to take a shot, Amber? 2T. Yeah, it'll in fact be 2T. 2D, 2D, 2D. Because if this is T, M to P is T, and K to M is also T. So K to P is 2T. Our next one says KAP is right angle and AM is still a median. If measure of angle K equals 40, what is the measure of KAM? Evan.
100 degrees. Okay, AM? Oh, 40.
40, okay.
Is the wrong one.
You found KMA. Yeah, absolutely.
Wouldn't it be 50?
We'll find out. I'm putting on 40 because it's fun.
Well, no, because it would be 40, 40, and the top angle is going to be...
So since M is a midpoint,
Wouldn't it 90 though?
this is the same as this angle. This is the same as that one. So when they say that measure of angle K is 40 degrees, this is 40 degrees. Hang on, we'll figure it out. So we're trying to find KAM. I'm trying to find that angle. Well, this is an isosceles triangle where base angles are the exact same size. So it has to be 40 degrees.
Wait, so. Oh, so. Oh, so that's.
I know this base angle. I know angle K is 40 degrees.
Oh.
I also know that this triangle is isosceles, which means the other base angle is also 40.
Oh. I forgot about the 40.
Yeah.
The MK.
Oh, okay. Which would also mean that KMA is 100 degrees, which could get us to AMP, which could get us to these two. So in fact, just knowing this one angle will get me the rest of the angles as well. Not to mention, we know that this is 90 degrees, so we can use that. All right, the next one says MP equals 6.5. What does MA equal? It's a tough one. It's a tough one. It's a tough one. Someone new. Someone I haven't heard from. Lydia.
6.5.
6.5. All right, good. Makes sense? We okay with that? It creates, the big thing about it is it creates a isosceles triangle. The easy ones are, like those ones over here. It's tough when I put an angle in there. All right, continuing on. We're going to get to a rhombus. A rhombus is a quadrilateral. It's a quadrilateral.
With 4 sides.
It's a quadrilateral with 4 sides, yes, because that is the definition of quadrilateral. But we're not going to put 4 sides in there.
Oh.
With 4 congruent sides.
Oh, I didn't want that.
I can see Grace just crossing this out. This is Grace's answer. Just cross out that blank. I just know it has 4 sides.
I couldn't even see the side because I was like covering it. So it's like...
It is 4 congruent sides. So in fact, a rhombus is something with 4 congruent sides. Therefore, every rhombus is a parallelogram. Why is every parallelogram a quadrilateral based upon a theorem that we know? Evan.
It has 2 sets of parallel sides.
2 sides with parallel sides? Well, we don't know they're parallel. I mean, they are.
Because
That's theorem 5.
Theorem 5.1, are you sure? Theorem 5.1 does not prove something's parallel. It says if it's parallelogram, then.
Theorem 5.
Theorem 5.4?
Yes.
Do we all agree it's Theorem 5.4? Everyone look at Theorem 5.4 and make sure that is correct. And that's because Theorem 5.4 says that opposite sides are congruent. Theorem 5.4 says opposite sides are congruent. So it is in fact that one. All 4 sides are the same, must be a parallelogram because opposite sides are congruent, both pairs. All right, that leads us to a few different awesome theorems with quadrilaterals. First of all, the diagonals of a rhombus are perpendicular. Did I say they're congruent? No, they're not necessarily congruent because you can see by the shape they would not be congruent. All I know is they are perpendicular and make 90 degrees. Do you think a rhombus could have diagonals that are congruent? Is a square a rhombus? Yeah? Oh, cool. All right, Theorem 5.14. Each diagonal of a rhombus bisects 2 angles of a rhombus. This one's important. This one's important. So that means if I draw 2 pairs of diagonals, let me do this in red. All 4 of these angles would be the exact same. And then the other 4 would all be the exact same as well. It is pretty cool. It's a good one to know. It's a good one to know. Yes?
Wait, the ones like the angles on like the side, like here, would those ones like this also be congruent to that since this is congruent to this? Or are they all like the same?
They would have to, because it's a parallelogram. Opposite angles have to be congruent, so the same rules apply to parallelograms. So this complete angle would be equal to that same complete angle. Yeah. Don't forget about all our parallel. You're going to forget those sometimes when we're dealing with these special ones, but anything that applied to a parallelogram applies to a rectangle, a rhombus, a square as well. All right, the very last one says, if 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So all that's saying is, hey, I have a parallelogram, so let's make it a parallelogram. Ching, chun, dum, chun, dum, chun, chun, chun. Yeah, we're saying, let's say I have a parallelogram. Let's say I have a parallelogram.
Oh, same shape, just add.
Let's say I have a parallelogram, and let's call it A, B, C, D. All I'd have to say is, if AB equals BC, then it's a rhombus.
Oh.
Kind of running out of room here. Rhombus. I just need to prove that 2 consecutive ones, are congruent, then all 4 have to be congruent. Because it's a parallelogram, so as soon as I say AB and BC are congruent, that automatically means that DC and AD are also congruent to it as well. Yes?
But wait, like, is a rhombus is a parallelogram? So, like, if you know that there's... Oh, but a parallelogram is not
I'm saying, what if I gave you a parallelogram, right? I give Grace a parallelogram, and I say AB equals BC, and I say, is it a rhombus? You're going to be able to say, yes, it is a rhombus, because you gave me 2 consecutive ones.
Okay.
However, if I would say AB equals DC, you'd say, I don't know if it's a rhombus yet. You have to give me the other sides.
Oh, okay.
Okay? All right, and then our big discussion comes down to a square. A square is a quadrilateral with 4 right angles and 4 congruent sides. So that means a square is a parallelogram. It is a rectangle. It is a rhombus. So every rule that applied to those 3 things also applies to a square. So everything that says rhombus in it applies to a square. Everything that's has to do with parallelogram applies to a square, and anything that has to do with a rectangle applies to a square. The square is the best of all worlds. The problem with squares, sometimes it makes you mess stuff up, because you start applying everything to squares, so you start applying everything to rectangles. Or you start applying everything to a rhombus. So you might say a rhombus diagonals are all congruent. They are not. That only applies to a rectangle, and a square diagonal is the exact same. All right. So you do have to kind of keep stuff in order. All right. Any questions? Questions going once, twice, 3 times, 4 times? Yes.
You missed
How do you
thrice.
find the angles in the rhombus if they're not right? Is it just
How do we find the angles? You have to be given some kind of information. So, yeah, we do not know they're 90, but in that kind of situation, so let's pretend I'm working with that bottom rhombus, right? And it's in a question. It might say something like, maybe this little angle here is 35 degrees. Find all the other angles, which would just be, okay, that's 35, that's 35, that's 35, that's 35. Consecutive angles equal 180. So this full angle would be 70. So this angle would be 110 divided by 2. I mean, I have to give you some information to find it. Yeah. Is that good?
kind of?
Kind of? Do you want me to do a different explanation?
No, it's okay.
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 I'll get it after the test. All right, other questions about what we learned today? So we learned about special parallelograms, specifically a rectangle, a square, and a rhombus. The big thing isn't memorizing the theorems or what numbers they are, just memorizing what they say. All right. Then let's go right into questions from the homework. We'll just do that. Grace.
Could you explain number 7?
Number 7. Number 7 says, name all the points that must be a midpoint of the sides of a triangle. In order to be a midpoint, both sides have to be equal, right? So if we look at D, D is surrounded by X and X. X is the same value, so D must be a midpoint. Because if X is 2, it'd be surrounded by 2 and 2.
Okay.
E is going to be a midpoint because Y is congruent to Y. And EF is not going to be a midpoint because this is Z, and this is Z plus 1.
Oh.
So it'd be kind of like 2, 2 plus 1, so it'd be 3 and 2. So because these aren't congruent,
Well,
that's not a midpoint.
Oh, I overthought that. Okay.
yeah. Yeah.
For number 17, I did with the I said. Oh wait a minute, never mind. For number what's it called? Number 15. I don't really get how the answer. I don't really get how it was answered.
Okay, if AB equals 12 and BC equals 2x plus 3y and BD equals 8x. So the first thing is all of these are parallel. All of those are parallel, and EF equals FG equals GH, which means all of these sections must also be equal. That was one of our theorems. So this says if AB equals 12, let me write that in up there. AB equals 12. BC equals 2x plus 3y. And then it says that BD equals 8x. So B to D equals 8x. So the first thing I'm going to set up is 2x plus 3y equals 12. Do you agree with that? Because this section has to equal that little section.
Yeah, but I don't get how it's solved because, I know how it's set up, but there's not a y in 8x equals 24.
That's okay. We'll solve it. So we have 8x equals 24. That's perfect. 8x equals 24. That's exactly what I got, which comes out to x equals 3, right?
Yeah.
Well, if x equals 3, I'm just going to take that x
Oh, and then you put it.
and plug it in for that x.
Oh, okay.
I think you were trying to do like elimination or you're trying to make like an elimination problem.
Yeah.
But as soon as you know one variable, just plug it into the other one.
Okay, and I have another question.
Hold on, I just want to make sure.
Oh, okay.
I don't like doing back to back. Yeah,
Can we do like 16 or 17?
16 or 17.
Set it up.
Sure. Do you have a preference at all?
No.
Okay.
I didn't know how to set them up.
Okay. Here's the big thing about this. So a segment joins the midpoint of two sides of a triangle. So this means that this is a midpoint. And this is a midpoint.
Oh wait, it's gonna be 4y plus 2.
So one of them is going to be 4y plus 2 equals what?
7 times.
Yep, I'm just going to do 7y minus 7. I just always skip to that. So that's one of my equations. And then my another equation is, so since these are midpoints, this is parallel to this. So Evan, this is half as large as this. That was our theorem. It said if these midpoints, or if these are parallel, then probably somewhere. So it says that if you're connecting midpoints, then this is parallel to this. And if those are parallel and one of them is a midpoint, then this is twice as big as that.
Oh, okay.
So there's a couple ways you can set it up. You can set it up as 2 times 3x plus 5 equals 12x minus 8. Or you could have said 3x plus 5 equals half of this. And then it's just solving for the things. And the same thing's going to happen here. Because these are midpoints, 5x minus 3y is going to have to equal 14, right?
Okay,
Because it's
yeah.
twice this. And then this will equal that. And then we're done. Okay? Does it answer both of them, kind of?
Yeah.
Okay, great.
So for, or like for the, to solve for x, so it'd be like for 16, so you do 6x plus 10 equals 12x minus 8, and then just solve for that.
Yeah, and just solve for x.
Oh.
And then plug it in, and then you got to solve for y also.
Oh.
Right, because you can solve for y up here.
Yeah.
Good? Yeah.
Another question about number 16.
Mhm.
So what if I got the correct answer, but I got it with a different method, like kind of using a different mathematical method, but like I still use like the problem, but like I set it up differently, and then the answer he had it, and I still got a correct answer.
Okay, how'd you set it up, I guess?
I
So you did 2 times 3x plus 5. I have that. So you did basically the same stuff I did.
it had a different way of solving it in the answer key.
Oh, yeah. Because my way, I think I know what you mean. In my way on the answer key, I think I did 1/2 times this one.
Yeah.
But it's going to come out to the same. Yeah.
Oh.
Yep. Whether you're okay dealing with halves or multiplying by 2, it's not going to make a big difference. Other questions? Grace.
Number 1.
Number 1, that's way
Yeah.
at the beginning. Okay, so it says if CD equals 24, so I'm going to go ahead and label that. I know it's kind of shaded, so I'll put it right there. If CD equals 24, then AB equals 1. Well, let's look real quick. So it says if points A, B, E, F are midpoints. So all of them are midpoints. So that tells me that B is a midpoint. I'll just put mid. A is a midpoint, which automatically makes AB parallel to CD. So that means that AB is half the size of CD. So if CD is 24, AB must be 12. And the same thing is going to apply to EF. EF is also midpoints, so it's going to be half as large as the base of that triangle. So EF will also be 12.
Okay.
Okay? Other question? Questions? Abby?
On 17, I don't know why it just didn't work out.
Number 17, did I make a mistake?
No,
Maybe?
I don't think so. I just like it didn't. Like I tried to do elimination.
Okay.
Like elimination, and it just like ended up as a weird number.
I have a little bit of time. Did it come out as weird on the answer key? I don't remember what I got as the answer.
Y equals 2 and x equals 4.
Okay, that's not too weird.
Yeah, that's not what I got.
Let's just go through it and make sure we did everything correct. So 5x minus 3y is actually going to equal 14, right?
Yep.
All right, and then 3x minus 2y is going to equal 8. I'm going to use elimination. I always like using elimination. So I'm going to go ahead and multiply the top by 2. And maybe I'll multiply the bottom by negative 3. That should give you... Is that what you did? Maybe I'll do the same method you
That's
did.
what I did.
Okay. So we have 10x minus 6x equals 28. And down here we'll have negative 9x plus 6y.
Oh, I didn't make the 9 negative.
Oh, okay. That would make... It's all the world of difference. Yep. So are you good then? Maybe? Okay. Other questions? All right, then the rest of the time you can work on your homework. Oh, it's on this. Okay. Then you can go ahead and start working. I'll go help Robin, and I'm going to check your homework.